Welcome back. This is our final video as it relates to the review for the final exam. We'll focus our energies on problems from Unit 12, Descriptive Statistics. Here's number 20. We're calculating a grade point average, which is a form of a weighted average. So you'll take a look at each of the four classes and we'll reference how many points you get for a letter grade and how many credits. So whistleblowing, the guy gets a 2 credit A. So you see the 2 referencing the number of credits, a 4 because each A is worth 4.0. So that's 8 quality points based on whistleblowing. Shoelace tying is a 4 credit course, but he only got a C. He's going to be stuck with Velcro. So the C's are worth 2, 4 credits, 4 times 2 for 8 quality points. Advanced sleeping, 5 credits. So that's pretty impressive. B got B. So 3 points for a B, 5 credits, 5 times 3 for 15 quality points. Good news is in business math, which is a 3 credit class, he gets an A. So 4 points for an A times 3, 12 quality points. To get your grade point average, we need to sum 2 columns. The number of credits, that's 14. And we also need to know the sum of those quality points that are earned, and there's 43. You will calculate grade point average by simply dividing 43 by 14. And this cat's got an average, good old Carl, of 3.1. So he probably didn't make Dean's List, but man, he got a serious boost there on whistleblowing. That was pretty impressive, snagging that A. And a B in advanced sleeping helped the old GPA as well. 3.1 takes care of problem number 20. Problem number 21 says here's a data stack, and we're going to be asked to find mean, median, and mode. So what I did first is I put the data in order. That's only necessary for median. So all right, I figured out that there were 12 data points after I stacked them in order. And so median in this case will not be one of the data points. In fact, it will be the average of the 2 that are in the middle. You see them bracketed with the 67 and the 55. To calculate mean, you're simply going to add all of those scores. That's how the 569 showed up. And you're going to divide the sum of the scores by the number of data points, which is 10. So the mean comes up 56.9. Since there's an even number of data entries, the median will not be one of the data points. It will, in fact, be the average of the 2 middlemost. So we're going to average 67 and 55. Yes, you guessed it. That means we'll add them, and then we'll divide that sum by 2. So your median comes in at 61. Mode is the score that occurs most often, if there is such a thing. And it looks like in this data stack, the only score that occurs more than one time is the 67. So it becomes the mode, having shown twice, everybody else only showing once. And that takes care of problem number 21. Let's move to 22. All right, 22's got a lot of work for us to do. The first part's pretty easy though. First part just says, here's a relatively small data stack. Find the range. The range is the difference between the largest and smallest of your data points. The largest I do believe is 133, and the smallest I do believe is 75. So there's a range of 58 from high to low. Simply a subtraction, you're good to go. All right, we are going to calculate variance and standard deviation by formula. And so I decided that I was going to go ahead and create a chart. First thing you're going to need is to calculate the mean, because that's important for your second and third columns here. So over here on the right-hand side, you can see that I'm going to find the mean of my data stack. So I'm going to add 117, 98, 133, 75, and 114. Divide by 5 because there were 5 data points. So the mean becomes 107.4. So down the first column, you'll see the data points listed. You'll also see in the middle column the reference that is each of those x's with the mean subtracted from it. So it was my calculator doing a lot of heavy lifting. So 117 take away 107.4, 9.6, and so on. As you fill in or populate that middle column, it's each of the individual x's from column 1 with 107.4 subtracted from it. Then to get column 3, we'll take all those deviations that we found in column 2 and square them. So a lot of calculator work going on. It is true that 92.16 is what you get if you square 9.6. Right? If you square negative 9.4, you will get 88.36. So the right side column is simply the sum of, or I'm sorry, it's simply the square of the values that you see populating the middle column. To find variance, we need to take a sum of the squares of those deviations. So you see that we are in fact going to add that rightmost column. to get to 19, 29, 24. When you're calculating variance, all right, it's called S squared. Since this is a sample, you divide by n minus 1, where n references the number of data points. So our data stack was only 5 points. So we're dividing by n minus 1, or 5 minus 1. So we're going to take that 19, 29, 24 and divide it by 4. So our variance amounts to 482.31. The last thing we're asked to calculate on this problem is the standard deviation. That's a measure of the spread. When you're comparing data stacks, if it's got a small standard deviation, then the scores don't spread out much. All right, so there, all this is the square root of the number we just calculated for part B. So we've got a standard deviation of 21.961. Again, the larger this is, the more data spreads out. We looked at our data stack. There's a fairly decent dispersion. I mean, you got numbers as small as 75, numbers as big as 133. So they're not clustered very much. They're kind of all over the place. And that's what happens when your standard deviation is pretty large. It reflects a data set that's kind of spread out. And that, my friends, is the final solution to our problem 22 review for final. And I continue to wish you well as you study. And if you have questions, shoot me an email. I will be posting all of these solutions in their entirety into the resource folder. A problem is an email away. So let me know if I can help you. And the final is on the way. Thanks. See you then.